Hello everyone, we will discuss today Dynamics chapter in Physics marks, high weight in section B and C, theory plus numericals, key subtopics. 1. Force and Newton's laws of motion. 2. Inertia and momentum. 3. Friction. 4. Circular motion. 5. Mass, weight, and free fall. 6. Important formulas plus past paper numericals. So guys, greet and quickly explain the plan. We'll cover all key concepts, formulas, and past paper questions from Dynamics so you're fully ready for the exam. Tease. We'll solve a tricky past paper numerical at the end. Continue watch video till the end. Force, a push or pull that changes motion. Discover how force affects speed, direction, and acceleration. Learn about force, motion, and Newton's laws. Understand the relationship between force and motion to grasp the fundamentals of physics. Explore real-world examples of force in action, from gravity to friction. So Newton's first law of inertia, states that an object remains at rest or moves with constant velocity unless an external force acts upon it. This principle helps predict object behavior under forces like friction, gravity, and thrust, and is crucial for understanding physics and mechanics. Mastering this concept is key to solving problems in physics and engineering. Newton's second law, force, F, equals mass, m, times acceleration, a, or F equals ma. This law shows how force affects an object's motion. It helps us understand how much force is required to accelerate an object. By applying this law, we can predict and analyze the motion of objects in various situations. Mastering F equals ma is key to solving physics problems. Newton's third law states that every action has an equal and opposite reaction. When two objects interact, they apply forces to one another that are equal in magnitude and opposite in direction. This law applies to all interactions, from the recoil of a gun when fired to the thrust of a rocket taking off. Examples: when you push on a wall, the wall pushes back on you with equal force. Inertia is an object's tendency to resist changes in motion. According to Newton's first law, objects at rest stay at rest. Objects in motion keep moving with constant velocity, unless acted upon by an external force. Key points: objects resist changes in motion. External forces change motion. Mass determines inertia. Examples: car keeps moving unless brakes are applied. The law of conservation of momentum states that in a closed system, the total momentum remains constant if no external forces act upon it. Momentum is conserved in collisions and interactions, meaning the total momentum before equals the total momentum after. This principle is key in understanding phenomena like billiard ball collisions and rocket propulsion. In simple terms, the total momentum street.
Friction is a fundamental force that plays a crucial role in our daily lives. It is a force that opposes motion between two surfaces in contact, and it can be classified into three main types: static friction, kinetic friction, and rolling friction. Types of friction. 1. Static friction. This type of friction prevents an object from moving when a force is applied. It is the force that needs to be overcome to start moving an object. 2. Kinetic friction. This type of friction slows down a moving object. It is the force that opposes the motion of an object when it is already moving. 3. Rolling friction. This type of friction resists the rolling motion of an object. It is the force that opposes the motion of a wheel or a ball rolling on a surface. Advantages of friction. 1. Walking. Friction allows us to walk and run by providing traction between our feet and the ground. 2. Braking. Friction is essential for braking vehicles, as it helps to slow down or stop the vehicle. 3. Writing. Friction between the pen and paper allows us to write and create marks on the paper. Disadvantages of friction. 1. Wear and tear. Friction can cause wear and tear on machinery and equipment, leading to damage and degradation over time. 2. Energy loss. Friction can result in energy loss as heat, which can reduce the efficiency of machines and systems. In simple, friction is a force that opposes motion, and it has both advantages and disadvantages. While it is essential for daily activities like walking and braking, it can also cause wear and tear and energy loss. Uniform circular motion occurs when an object moves in a circular path at a constant speed, but its direction changes continuously. Even though the speed remains unchanged, the change in direction means the object is constantly accelerating toward the center of the circle. This inward acceleration is caused by the centripetal force, given by the formula F equals frac mv²2 r, whereas the mass of the object is its speed, and is the radius of the circle. Centripetal force is always directed toward the center of the circle, keeping the object in its curved path. Examples include satellites orbiting Earth, where gravity acts as the centripetal force, and vehicles turning on curved roads, where friction between tires and the road provides the necessary force to maintain the curve. Mass, weight, and free fall are fundamental concepts in physics. Mass refers to the amount of matter in an object, measured in kilograms and remains constant regardless of location. Weight, on the other hand, is the force exerted on an object due to gravity, which can change depending on the gravitational field it's in. Free fall occurs when an object falls solely under the influence of gravity, accelerating downwards at 9.8 meters per second squared meter per square second on Earth. The distance an object travels in free fall can be calculated using formulas, illustrating the relationship between mass, weight, and gravity's effect on motion. If you want to master the dynamics chapter, here's the golden formula for success. First, understand the core concepts: Newton's laws, mass, weight, and free fall, not just definitions but how they apply in real life. Next, focus on the key formulas like and practice them through different numerical problems. Don't skip tricky topics like centripetal force and motion on curved roads, they are common exam favorites. After every practice session, challenge yourself with past paper questions to strengthen speed and accuracy. Remember, learning is like a moving car. Without force, your effort, it won't accelerate. If you found this useful, don't forget to hit that subscribe button, drop a like, and share this video with friends because knowledge grows when we share it. Goodbye, best luck for your exam. If you want to master the dynamics chapter, here's the golden formula for success. First, understand the core concepts: Newton's laws, mass, weight, and free fall, not just definitions but how they apply in real life. Next, focus on the key formulas like and practice them through different numerical problems. Don't skip tricky topics like centripetal force and motion on curved roads, they are common exam favorites. After every practice session, challenge yourself with past paper questions to strengthen speed and accuracy. Remember, learning is like a moving car. Without force, your effort, it won't accelerate. If you found this useful, don't forget to hit that subscribe button, drop a like, and share this video with friends because knowledge grows when we share it.